Hello everybody, this is paper 1 from May 2023. This is time zone 2. Okay, question 2, 6 marks. Angel has $520 in his savings account. Angel considers investing the money for 5 years with a bank. The bank offers an annual interest rate of 1.2% and it's compounded quarterly. Quarterly means 4 times per year. 4 times per year. Part A asks us to calculate the amount of money Angel would have at the end of 5 years with the bank. Give your answer correct to 2 decimal places. So these little things are important because they can potentially add up. For a 3-mark question, the idea that you could lose 1 mark just not having the correct number of digits, even if you understand it and get the procedure all correct. So these things are careful and sometimes shows the importance of close reading. So let's see what we can do. 520 is our initial value, and we have it in for 5 years. Let's go and look at the financial solver for 1 sec. So I'm just going to bring up the calculator screen. There's 2 ways to do this, of course. One way is the financial solver, and the other way is just going to be using our compound interest formula. So here's our finance solver. I'm just going to use this to write out each of these values on the page. So we have N, I, PV, our present value, payments, number of payments we're making per year, the final value, and then we have payments per year. So our payment is the amount, the size of the payments we're making. CPY is compounding periods per year, and then the very last one is payment at. So when are the payments being made? Okay. So let's go ahead and work this out using the financial solver, and then we'll use the compound interest formula. Alright, so interest rate is always the most straightforward one to put in. In this case it's 1.2%. Angel has $520 in his savings account, so this is $520. We imagine this money is no longer in Angel's possession or this individual's possession. It is now out of his hands. So in some sense we write money flowing out, money flowing in. So this is 520 no longer in his hands. The payment in this case is 0. It's just he's not making any continuous payments. If it's just one payment, how many continuous payments is he making? He's not making any. Final value is what we want to find out. And in this case, our compounding periods, we're going to compound quarterly. And generally speaking, if we're not making any payments, our PPY should be the same as our CPY. And this can potentially be a little confusing, and it's actually maybe not a bad reason where for simple compound interest it's often better to use a formula. But let's work this out just using the finance solver first, and then we can find it using the compound interest formula later. Payment is at the end. I don't know if it explicitly states that, but banks would pay their interest at the end of the month, not at the beginning. Lastly, we have PPY relates to this N. And in this case, 4 payments per year times 5 years. So 5 times 4, there are 20 payments. And this is essentially the banks giving us 20 installments of interest over this 5-year period. So over 5 years, they're going to give us interest 4 times every year, total of 20 interest payments. So let's go and write this into the calculator and get our results. So 20 payments, 1.2, present value, money flowing out. It's not making any payments. The final value is what we're interested in, so let's leave that empty. Payments per year and compounding period for year. We'll keep these as the same in this case. If we're not making any payments and we're just looking for compound interest, keep PPY and CPY the same. Alright, final value, $552 and 1.054 after that. So they asked us the 2 decimal places. We'll have to be mindful of that. So 552.11 in this case. Alright, let's go back to the document and write this out. So final value, can use a different color I suppose. Actually let's just write it out here. This is what we were trying to find. Therefore our final value is equal to $552.11. to 2 decimal places. Okay. The other way to do this, because this CPY and PPY can sometimes be a little confusing, and for a 3-mark question, one mistake on the financial solver would just lead to potentially 0 marks or potentially just 1 mark. And so it's a little risky. Potentially, there's a lot that could go wrong. Not getting N, for example, or with this CPY and PPY being different, or if you forget to put end. Potentially a lot could go wrong. So let's go to the formula booklet and let's look at compound interest. So if there's no payments being made, no constant payments being made, we can just use our compound interest formula. And here it is. This is our compound interest formula. Present value is equal to, final value is equal to present value times 1 plus R, our interest rate, K, number of compounding periods per year, and N, the total number of years we have this investment in a bank. So let's write that out. To be honest, I think this is actually the easier way. So here's the alternate method. Final value, present value, 1 plus our interest rate over 100 times compounding periods per year times number of years in the account, again, by compounding. So let's write this out. Here's $520. We're going to multiply this by 1 plus interest rate, 100 times compounding for 4 times a year. It's in for 5 years, and then we'll multiply this by 4 once again for that total of 20 payments, essentially. Okay, let's work this out on the calculator. 520 times 1 plus 1.2, 100 times 4, and then we'll raise this to the power of 5 times 4, or 20 if we wanted. And there it is once again, $502 and 10.5 cents, or 11 cents. Okay. And to be honest, I think that's the easier way. I'd recommend that way. I think it's less prone to errors. Okay, let's go back to the document. Instead of investing the money, Angel decides to buy a phone that costs $520. At the end of 5 years, the phone will have a value of $30. It may be assumed that the depreciation rate per year is constant. Calculate the annual depreciation rate of the phone. Okay. So once again, we can actually use our compound interest formula, or we can use the financial solver. And this time I'm going to actually reverse the order. Let's get a clean line here, and we'll start on question B. So here's A, here's B. So let's reverse the order and write out final value, present value. We'll use our compound interest formula. So in this case, we have $30 at the end. The final value is equal to 30. The present value of the phone was equal to $520. 1 plus, and in this case, we want to know the value of the depreciation rate. So that's our unknown. 100 times, in this case, the depreciation rate per year is constant. So it's not like we have any kind of compounding or any kind of fractional compounding per year. So in this case, we're actually just going to divide our interest rate by 100, and we're not even going to need any K value. And then N, the number of years, is 5. After that, we can go ahead. We've got some equation just in terms of R, one variable, so we can go ahead and N solve. I'm just thinking about this now. Often exponential equations are a little funny in NSolve, so I'm a little unsure whether the calculator will accept this. So let's go to the calculator and try to work it out. Menu, algebra, numerical solve. 30 is equal to 520 multiplied by 1 plus, and in this case we have R over 100. We want to raise this to the power of 5. And let's ask the calculator to solve for R. And in this case, it worked out okay. So this negative depreciation rate means that our interest rate is now not increasing. The value of this phone doesn't increase through time, but it is negative. It depreciates rather. So we have negative 43.47 or 43.5%. That's the value that the phone loses every single year. So let's go back to the document and write this out. So in this case, R is equal to the annual depreciation rate, and the annual depreciation rate is, what was it once again? 43.5%. And that should do it. If you want to work this out using the compound interest formula, we certainly can. Or sorry, not the compound interest formula, but the financial solver. We certainly can, and I'll show you how to do that really quick, or as quick as possible. So alternate method, here we go. NI, PV, PMT, final value, payments per year, compounding periods per year, and then payment at the end. We'll leave that empty because we don't need that in this case, but it's always at the end. So in this case, the interest rate is what we're trying to find, the depreciation rate. The present value is going to be the value of the phone. And in this case, we'll still put negative 520. In this sense, the value is locked up in a phone. And I think, to be honest, we could actually switch the values. We could put this as positive, and our final value would be negative. Or in this case, we can just imagine it's 520 values, but our final value is $30. So we can imagine that, in this case, the logic is this. We have this $520 locked up in the phone, and at the end we are going to sell it, or the value that we have available to us at the end is going to be $30. I'll show you what happens if we were to put positive, positive. The calculator would just give you an error, and that's usually just a signal that this present value and final value you want to keep different. Okay, payment is going to be 0. PPY, CPY, we'll just leave this as 1. What essentially we're saying is that the depreciation rate, which we already know is 43.5%, happens every year. That is to say, 43.5%. This phone loses 43.5% of its value every year. And number of years is just 5. Remember, these two things are related. So PPY 1 times 5. And that should be it. Okay, let's type that in, and I'll show you the error that you get potentially if you were to try to work it out and forget the signs. So N is 5. Let's imagine that this is 520. Payment is still 0, and the final value is 30. So the interest rate is what we're trying to find here. PPY is 1, and CPY is also 1. Payment at the end, this is good. So if you were to type this in on your calculator and keep this present value and final value the same, you would get no sign change, which means that essentially the calculator is telling you that it's not possible. You can't go from 520 to 30 because, well, what I believe the calculator is understanding is that if you have this in your possession, it can't go from 520 to 30 with any kind of interest change. There's nothing we can multiply this by. But if we change this sign to negative 520, then it will give us our depreciation rate, or the change in the value of the phone every single year, which is 43.5% once again. So whenever you get that no sign change, often due to this present value and final value being different. Okay. Let's go back to the document and continue on.